physical factors in agriculture.
Agricultural activities in all ages have centered mainly around the growth of crops, which is dependent on suitable moisture, temperature and soil conditions. Basically, agriculture of an area needs to be studied against the backdrop of its physical environment, that is, the natural land resources. Agricultural activities are primarily influenced by the combination of natural environmental conditions, the compound of terrain, climate, soils and water resources. These factors determine the extent and magnitude of usefulness of arable land for different agricultural operations and the types and number of crops that can be grown on the same field in the course of an agricultural year. Jasbir Singh, 1974. It demarcates agricultural realms or domains. It is an essential prerequisite in understanding the resultant agricultural type. In this lesson, let us examine how these factors influence the overall agricultural development from the following headings: physiographic factors, edaphic factors, climate, water resources.
Physical factors affecting Indian agriculture. Physiographic factors. Physiography is the nature of surface earth, leveled or sloppy, is known as topography. Topographic factors affect the crop growth indirectly. Terrain or topography plays a significant role in land use variation. Thus, it has a tremendous influence on the growth and distribution of crops, especially so where it comprises of diverse landforms and lithology. There are three most significant aspects of terrain, namely altitude, slope, and drainage texture. The direct effect of terrain operates particularly through elevation, rugged relief, and slope. These determine the pace of cultivation and farm mechanization and the degree of accessibility and flooding on the lower levels. The primary consequence of altitude is the decrease in air pressure with increase in elevation. Only in exceptional cases, as in the Himalayan states of India, this phenomenon has agricultural significance at considerably high altitudes at which climatic controls such as temperature, precipitation, etc. limit land utilization. Usually, the rarefied air of the high mountains increases transpiration rates of plants, which restricts growth. Soils at high altitudes are desiccated as well as frozen, thereby creating hazards to agricultural activity. There is an increase in precipitation in highlands as the capacity of air to hold moisture varies directly with its temperature. Consequently, agriculture gets hampered by heavy rainfall and soil erosion up to a specific height. Similarly, at places with high altitude, sufficient moisture results in snowfall and makes agricultural activity very difficult. Higher elevations also cause variations in rainfall distribution. On the windward slope, the rainfall is usually heavy and the leeward side it is much less, which has led to regional variation in cropping patterns. Slope is one of the important physiographic aspects influencing the agricultural land use of an area. The obvious influence of slope is in the form of restraint on cultivation and accessibility. With the increase in steepness of slope, the use of even the simplest of farm machinery becomes difficult. Steeper slopes are generally avoided and ploughed only if warranted by population pressure. The most satisfactory categories of slopes, as listed by British Geomorphological Research Group, used for land use interpretation, is listed below. On a sloping land, water flows down before it finally gets absorbed in the ground. The quantum of precipitation lost by runoff increases correspondingly, which is why sloping land is found usually dry despite heavy rainfall it may receive. Both runoff and soil erosion vary according to the steepness of slope. It has been proved experimentally by Conkey and Bertrand 1959 that if the degree of slope is doubled, the erosion per unit area increases 2.5 times. At the same time, on a slight slope, sand may erode less than clay, but on a steep slope, the reverse is true. That is, clay may erode more than sand, which causes damage to the standing crops. Irrigation efficiency is bound to decline on sloped fields unless effective measures such as terracing and leveling of irrigation fields with the provision of retaining walls are adopted. Irrigation water is conducted from upper slope to down slope and from terrace to terrace by artificial channels and weirs. It entails almost no erosion. However, seepage loss through this system is enormous. Edaphic factors. The edaphic or soil factor in the cropping system is an important determinant of productivity and can be a defining characteristic of the farming systems that can be employed within a region. In fact, it is agriculture that modifies soil except certain virgin soils which can retain their original characteristics. It forms the physical base for any agriculture. 5 major factors largely control the types of soils that develop. These are climate, particularly temperature and precipitation, living organism, especially the natural vegetation, nature of parental material, texture and structure, chemical and mineralogical composition, topography of an area, and the time that parental materials are subject to soil formation. Buckman and Brady, 1969. Soil characteristics, particularly the physical, help us to know about the distribution of crops and the selection of soils for the specific crops. This may be called the selective rather than the prohibitive influence of the soils. The relative distribution and abundance of the crops and weeds within the cropping system is a function of the soil factor. The soil is a 3-phase system: solid phase, minerals and organic solids in the soil; solution phase includes water and materials dissolved in soil water; gaseous phase, the soil atmosphere. The soil provides anchorage for the plant and a ready source of water and nutrients to be accessed by the root system for growth and development and for yield of the crop. But the soil is full of life itself and is the habitat for many organisms, some beneficial and some harmful for crop production. The capacity to retain and conduct moisture through the soil profile is largely dependent on its texture and porosity. The friability of soils is also to be considered. For instance, during hot, dry period, heavy clay soils become hard-baked and get poached badly, while under heavy rainfall, these turn too heavy and sodden, thereby restricting the cropping multiplicity. Crop growth is determined to a considerable extent by the amount of nutrients in the soil. The 3 nutrients, namely nitrogen, phosphorus, and potassium, contribute to soil fertility. Differences in soil fertility have the greatest impact on agricultural land use. Salinity and alkalinity is a limiting factor in respect of the fertility in many parts of the world, particularly under irrigated conditions in semi-arid and arid regions of the developing countries. It is measured in terms of pH value, that is, the concentration of hydrogen ions H plus and negatively charged hydroxyl ions OH negative. Salinity means the predominance of chlorides and sulfates of sodium, calcium, and magnesium in the soils, and alkalinity implies the dominance of sodium salts, especially sodium bicarbonate, which interferes in the growth of plants. Plants growing in different soils exhibit variations in their physiological and morphological features. Based on the characters of soil, Warming 1990 has classified the plants into 5 groups, namely oxalophytes, plants growing in acidic soils; halophytes, plants growing on saline soils; psammophytes, plants growing on sandy soils; lithophytes, plants growing on rocks; chasmophytes, plants growing on rock crevices. The growing period for most crops continues beyond the rainy season, and to a greater or lesser extent, crops mature on moisture stored in the soil profile. However, the amount of soil moisture stored in the soil profile and available to a crop varies. Example, with depth of the soil profile, the soil physical characteristics, and the rooting pattern of the crop. Soil erosion and waterlogging have become major problems with soils. As such, these should be checked by adopting contour farming, terrace farming, constructing dams and dikes. Climate. In both developed and developing countries, the influence of climate on crops and livestock persists despite irrigation, improved plant and animal hybrids, and the growing use of chemical fertilizers. The continued dependence of agricultural production on light, heat, water, and other climatic factors impacts on global agriculture. Comparison of temperate and tropical agriculture. The tropics are defined as a geographical area lying between 23.5 degree north and 23.5 degree south latitude, while the temperate regions are found above these parallels. Climatologically, the tropics are characterized by high year-round temperatures, and weather is controlled by equatorial and tropical air masses. Tropical precipitation is primarily convective. In the more humid tropical regions, annual rainfall is often above 2000 millimeters and falls in almost all months of the year. In the drier tropics, rainfall can fall below 50 millimeters and be very seasonal. The remainder of the region lies between these precipitation regimes with distinct wet and dry seasons. Agriculture is frequently limited by the seasonality and magnitude of moisture availability. In the mid-latitude temperate zone, weather is controlled by both tropical and polar air masses. Precipitation here occurs along fronts within cyclonic storms. The temperate region also has many different climate regions with warmer and cooler temperatures and seasonal rainfall. Temperate agriculture is often characterized predominantly limited by seasonally cooler temperatures. Reported experiments have shown that even though yield per day is often higher in the tropics, total crop growth season is shorter. Hawes et al., 1983. Leaf area expansion and phasic development are faster in the tropics because of higher temperatures during vegetative growth. Nevertheless, crop yields are consistently found to be higher in temperate regions than in the tropics. FAO 1990. Numerous factors such as soils in the humid tropics tend to be highly leached of nutrients and are therefore unproductive because of high temperatures, intense rainfall, and erosion. Soils in the drier tropics are often hampered by accumulations of salt and lack of water. Barrow, 1987. Temperate soils are generally viewed as more favorable to agriculture than tropical soils because of higher nutrient levels. Agricultural production is also severely limited in many humid tropical regions by the wide range of weeds, pests, and diseases that flourish in consistently warm and moist climates. The growth of some crops and varieties which require long hours of daylight to reach maturity is also limited by the invariable day lengths of the tropics. Solar radiation, which is critical to plant growth and whose intensity is controlled by the angle of the sun, day length, and cloudiness, is lower in winter and higher in summer in temperate zones. In the tropics, solar radiation is often limited by cloudiness during the rainy seasons. Agricultural crops and cropping systems have been developed for and adapted to these varied regimes of climate, soil, diseases, and pests. Hawes et al. 1983. The main commercial agricultural crops and their adaptations include cassava and sugarcane, which only grow in tropical areas and have a crop duration of 1 year or longer. Cassava is drought resistant, but sugarcane requires irrigation in dry areas. Sorghum, groundnut, and sweet potato, which grow in both tropical and subtropical regions in relatively dry seasons. Rice, which is mainly grown in tropical and subtropical zones in the rainy season or with irrigation. Maize and field beans grow in both zones, preferably with seasons with enough rain. Wheat, soya bean, and potato are crops of the subtropical and temperate zones and grow in the tropics at high, cooler elevations. Sugar beet is grown only in the temperate zone. In both temperate and tropical regions, irrigation has been developed in areas where dry seasons exist and adequate water can be reserved from other seasons or brought in from adjacent regions. Irrigation is an important buffer against climate variability and climate change. About 20% of the world's cropland is irrigated, mostly in Asia, producing about 40% of the annual crop production. Water resources. Agriculture is a major user of water resources and also contributes to water pollution from excess nutrients, pesticides, and other pollutants. Sustainable management of water in agriculture is critical to increase agricultural production. Availability of water is the only redeeming factor for farming in dry climate. Inadequate and poor water supplies to otherwise productive dry lands cultivated by assiduous farmers produce only inferior and subsistence crops. On the other hand, sufficient and assured supply to the farming systems would yield superior, stable, diversified, and commercially profitable farming. There are 4 major sources of water available to man: surface water, groundwater, atmospheric water, and the oceans. Of them, surface water in the form of rivers, streams, and lakes is by far the most important source which can be used for irrigation purpose. Groundwater is equally important, particularly in areas which lack surface water. Its ability and efficiency for use depends upon the depth, quality, and quantity. Use of pure water derived from the atmosphere and the oceans may become significant if and when technological advances make it available. Many parts of the world are endowed with vast resources of irrigation water available from groundwater and surface water, along with tropical or subtropical climate with potentials to grow crops round the year. The third source of water is the atmospheric water or water vapor. The surrounding air carries vapor into the clouds that eventually becomes rain. Indeed, atmospheric water has twofold advantage. First, it is found everywhere above the surface of the land, and second, it is salt-free. Oceans and inland seas form a fourth source. These are static and indispensable sources of water containing about 93% of the Earth's water, which is otherwise not usable because of the salts and other contaminations. Reclamation of such water is a probable way to supplement traditional water supplies. Perhaps its use would be of great value to the areas along the coasts which are in need of supplementing the short supplies of agricultural water. Groundwater interacts with surface water by supplying stream flow and maintaining wetlands in times of low precipitation. Overpumping of aquifers can lead to lowered stream and lake levels and desiccation of wetlands. Waterlogging and salinization are diminishing the productivity of irrigated lands. Surface water provides habitat for wetland and riverine ecosystems. Water and pollution. The quality of water from different sources varies widely. Precipitation absorbs gases from the atmosphere and removes particles from the air. When the precipitation strikes the ground, it becomes surface water runoff or enters the ground. The surface water flows into larger and larger channels, ponds, lakes, and rivers until some of it reaches the sea. Along its course, surface water picks up both organic and mineral particles, bacteria, and other organisms, as well as salts and other soluble substances. The water in lakes and swamps sometimes acquires odors, tastes, and colors from algae and other organisms and from decaying vegetation. Water resources of India. Location of a country is a key to its identity. It determines the important aspects like climate, vegetation, agriculture, resources, etc. India is the largest country in terms of area and population in South Asia. It is the seventh largest country in the world and accounts for nearly 2.42% of the total geographical area of the world. India has the topographical diversity belonging to the different geological ages. This includes the Great Himalayas, the Northern Plain, the Thar Desert, the coastal plains, and the peninsular plateau. There are high mountain peaks in some areas, while in others lie the flat plains formed by rivers. Apart from variation in landform, the country has varieties of climatic conditions and soil types. India has tropical monsoon climate as a whole. These physical variations, along with other factors like availability of irrigation, use of machinery, modern agricultural inputs like high-yielding varieties, HYV of seeds, insecticides, and pesticides have played their respective roles in the evolution of different farming practices in India. Despite the large-scale expansion, only about 1/3 of total cropped area is irrigated today. As a consequence, 2/3 of cropped areas is still dependent upon monsoon. As you know, monsoon in India is uncertain and unreliable. The country receives over 80% of its rainfall during the period of southwest monsoon. But the monsoon is highly variable, and some parts of the country the rainfall is too meager for successful agriculture. This has become even more unreliable due to change in climate. Rain-dependent areas can be broadly split into two: dry lands, which receive less than 750 millimeters of rain a year, and rain-fed areas, which receive more than 750 millimeters. Comprising arid and semi-arid ecosystems, dry lands stretch from Gujarat in the west till eastern Madhya Pradesh and from Rajasthan till the southern tip of India. Since India has both tropical and temperate climate, crops of both the climates are found in India. There are very few countries in the world that have variety comparable to that of India. India comprises more than 20% of the world's irrigated land. Most of the irrigation in dry areas of Punjab, Haryana, and western Uttar Pradesh was carried out by the excessive use of groundwater. Today, fresh groundwater situation in these states is alarming. In the coming few years, if this type of farming practice continues, these states are going to face a water famine. Due to climate change and temperature increase, there would be an increase in sea level, more intense cyclones, unpredictable rainfall, etc. These changes would adversely affect the production of rice and wheat. Specifically, rise in temperature in winter would affect production of wheat in North India. Production of rice would be affected in coastal areas of India due to ingress of saline water and increase of frequency of cyclones. The level of scientific and technological development has a great bearing on agriculture. Farmers using primitive methods obtain poor yields, but on the other hand, where farmers are using modern farm technology in the shape of fertilizers, pesticides, machinery, and high-yielding variety seeds, etc., the farm yields are high. The system of land tenure also plays a significant role in the patterns and productivity of agricultural crops.
India has diversified topography. The country has Himalayan mountain ranges extending from Jammu and Kashmir in the west to Arunachal Pradesh in the northeast. India receives over 80% of its rainfall during the period of southwest monsoon. But the monsoon is highly variable, and some parts of the country the rainfall is too meager for successful agriculture.